section will apply derivatives in order to determine the limits of indeterminate forms where we can't use methods learned in Unit 1, a topic known as L'Hopital's rule, or the most important topic of this lesson, you guys say it with the French accent, L'Hopital's rule, 3.5. So, suppose I have functions f and g that are differentiable everywhere, and that at x equals a, we have the limit as x approaches a of f of x equals f of a equals 0. F is continuous since it's differentiable, if we recall. And the limit as x approaches a g of x equals g of a equals 0. Again, g is differentiable as well, so it's continuous as well, which means that the limit as x is closer to a of g equals the actual value of g at x equals a. So as a result, if we evaluate the limit of x approaches a of f of x divided by g of x by direct substitution, we will obtain an indeterminate form, 0 divided by 0. In these cases, we could apply the methods from Unit 1, but that's not always possible. So we can apply a rule known as L'Hopital's rule, that states that if two functions f and g are differentiable everywhere, and the limit of their quotients as x approaches a equals 0 divided by 0 by substitution, the indeterminate form can be removed and the limit evaluated by evaluating the limit as x approaches a of the first derivative of f divided by first derivative of g instead. That is, in more succinct terms, if the limit as x approaches a of f divided by g is equal to 0 divided by 0, then we can circumvent this by finding the equivalent limit of x approaches a of the f prime of x divided by g prime of x. So in a nutshell, if we run an indeterminate form, we can just find the limit of the ratio of their derivatives instead, and we'll get the same result, circumventing this 0 divided by 0. So it can be used for any determinate form, i.e. Infinity divided by infinity as well, not just 0 divided by 0. L'Hopital's rule can only be used if the following conditions are met. The limit is of the form f of x divided by g of x as x approaches a, and the limit is indeterminate when evaluated via substitution. So if you have a limit that you can evaluate via substitution, L'Hopital's rule will not work. So here's just a brief proof if you are interested. We can rewrite the limit as x approaches a, f of x divided by g of x, as the limit as x approaches a, f of x minus 0 divided by g of x minus 0. But if we recall from our prompt, f of a equals 0 and g of a equals 0, so we can replace the zeros right here with f of a and g of a. Now we do a little bit of manipulation where we divide the numerator of our limit by x divided by x minus a, and we divide the bottom of our limit by x minus a. This is perfectly fine because the x minus a's will cancel out anyway, leaving us with our original limit in the first place. So what we can take note of is that using a definition of derivative, this numerator right here is equal to the derivative of f, and this right here is equal to the denominator now is equal to the derivative of g. So we get that the limit as x approaches a with f of x divided by g of x is equal to limit as x approaches a of the first derivative of x divided by the first derivative of g. So let's look at L'Hopital's rule in action. So let's say we have x approaches 0 of the function e to 2x minus 1 divided by 4x. If we just plug in 0 by direct substitution, we're going to get e to 0th power minus 1 divided by 4 times 0, which is just going to give us 0 divided by 0. Notice that we cannot apply any techniques from Unit 1 here, so L'Hopital's rule gives us a way to circumvent this. We take the derivative of the numerator, which in this case is going to be 2 times e to 2x by applying the chain rule, and we take the derivative of the denominator, the derivative of 4x will just be 4, and now we can take the limit as x approaches 0 without getting an indeterminate form. So now we're perfectly fine. We can plug in x equals 0 automatically here in order to get 2 times e to the 0th power divided by 4, or 2 divided by 4, which gives us 1/2. So all we have to do with L'Hopital's rule in this case is find the derivative of our numerator, find the derivative of our denominator, and then take the limit as x approaches a specific value of the derivative of the numerator divided by the derivative of the denominator. Nothing more you have to do than that. So there are times where L'Hopital's rule will not work with one go-around, and you have to use multiple go-arounds. So in those cases, we just keep repeating the procedure until we get a answer, and we're able to evaluate our limit by substitution. So in theory, it could go on for an infinite amount of times, but in practice, you only see it about maybe 2-3 times at most. 3 times at most, definitely 2. So let's say we're looking at the limit as x approaches positive infinity of 12x squared minus 3x minus 18 divided by 3x squared minus 8x plus 12. We recognize this as a horizontal asymptote of this rational function, so we could apply techniques from 1.5 and take 12 divided by 3 to get our horizontal asymptote, 4. But we can also apply L'Hopital's rule. So for this problem right here, if we plug infinity in, we're going to get infinity divided by infinity in indeterminate form. So what we can do here is we can apply L'Hopital's rule and take the derivative of the numerator and the derivative of the denominator in order to evaluate our limit. So the derivative of 12x squared minus 3x minus 18 is 24x minus 3. The derivative of 3x squared minus 8x plus 12 is 6x minus 8. However, if we notice here, if we still plug in positive infinity, well, it's not going to work because we're still going to get infinity divided by infinity. It's not going to work. So again, we can apply L'Hopital's rule again. Now our limit, now we take the first derivative, or excuse me, now we take the derivative of our numerator. So derivative of 24x minus 3 is just 24. And then the derivative of 6x minus 8 is just 6. And so now the limit is going to be, the limit of our rational function as x goes to positive infinity is going to be equal to the limit as x goes to positive infinity of 24 over 6, or just 4. And that is L'Hopital's rule in a nutshell.